Good morning to all. Today we are discuss about Unit 3 Symmetrical Fault Analysis. Introduction, Assumption in Short Circuit Analysis, Symmetrical Short Circuit Analysis using Thevenin's Theorem, Bus Impedance Matrix Building Algorithm without mutual coupling, Symmetrical Fault Analysis through Bus Impedance Matrix, Post-Fault Bus Voltages, Fault Level, Current Limiting Reactors. Introduction to Short Circuit Studies. Fault. A fault in a circuit is any failure which interferes the normal flow of current. The fault are associated with the abnormal change in current, voltage and frequency of power system. The fault may cause severe damage to the equipment if it is allowed to persist for a long time. So, it's very much important to isolate the healthy sections from the fault using protective devices such as relays and circuit breakers immediately. Causes of faults. First one, insulation failures of equipment. Second one, flashover line initiated by a lightning stroke. Third one, due to permanent damage to conductors and towers or due to the accidental fault operations. Classification of faults. Classification of faults. Power system fault. Open circuit fault, short circuit fault. Open circuit fault, one conductor open, two conductor open, three conductors open. Then short circuit fault, symmetrical fault. Another one is a unsymmetrical fault. Symmetrical fault means three phase short circuit fault, three phase to ground fault. Then unsymmetrical fault, single line to ground fault, double line to ground fault. Then next one is the line to line fault. Relative frequency of occurrence of faults, severity. Types of faults, relative frequency of occurrence faults. Three phase fault 5%, double line to ground fault 10%, line to line fault 15%, single line to ground fault 70%. Need for short circuit studies. Short circuit studies are essential in order to design or develop the protective schemes for various parts of the system to estimate the magnitude of fault current for the proper choice of circuit breaker and protective relays. Assumption in short circuit studies, transformers are represented by their leakage reactance. The magnetizing current and core fuses are neglected. Resistance shunt admittance are not considered. Star delta phase shifts are also neglected. Transmission lines are represented by series reactance. Resistance and shunt admittance are neglected. Synchronous machines are represented by constant voltage sources behind substantial reactance. Armature resistance, saliency and saturation are neglected. All non-rotating impedance loads are neglected. Induction motors are represented by just as synchronous machine with a constant voltage source behind a reactance. Similar motor loads are generally neglected. Symmetrical faults. This type of faults is defined as a simultaneously short circuit across all three phases. It occurs frequently, but it is the most severe type of fault encountered because the network is balanced. It is solved by their basic using Thevenin's theorem or bus impedance matrix or KVL and KCL laws. Need of fault analysis of a power system. To provide information for the selection of switchgear, settings of relays and stability of system operation. A power system is not a static but changes during operation, switching on or off generators and transmission lines. During planning, addition of generators and transmission lines. These causes of electric systems faults in insulation breakdown compromise. This breakdown can be due to variety of different factors. First one is lightning ionizing air, wires blowing together in the wind, animals or plants coming in contact with the wires. Then fourth one is a salt spray or pollution on insulators. Next, a fault in a circuit is any failure that interferes with the normal flow of current to the load. In most faults, a current path from between two or more phases or between one or more phases and the neutral ground. Since the impedance of a new path is usually low and excessive current may follow. Flashover. It is a condition when the voltage difference between the line and ground is large enough to ionize the air around insulators and thus provide a current path between a phasor and a tower. Fault currents are causes equipment damage due to the both thermal and mechanical process. Goal of fault analysis is determine the magnitude of the current present during the fault. First one, need to determine the maximum current to ensure devices can severe the fault. Then second one, need to determine the maximum current circuit breakers need to interrupt correctly size the circuit breakers. Analysis type. First one, power flow, evaluate normal operating condition. Second one, fault analysis, evaluate abnormal operating condition. First one, fault types. Balanced fault or three-phase faults or symmetrical faults. System remains balanced. These faults are relative, rare, but are the easiest to analyze, so we'll consider them first rarely occurring faults. Unbalanced or unsymmetrical faults. The system is no longer balanced, very common but more difficult to analyze. Then types of unsymmetrical faults are, first one is a single line to ground fault, 75% of total fault. Then second one, line to line fault, 15% of total fault. Then third one is a double line to ground fault, 10% of total fault. Results used for specifying ratings for circuit breakers and fuses productive relays settings. Second one, specifying the impedance of transformer and generators. Then last one, fault analysis. First point, magnitude of fault currents depends on first the impedance of network, second one the internal impedance of generators, then third one the resistance of the fault arc resistance. Second, network impedances are governed by transmission line impedances, transformer connection and impedances, grounding connections and resistance. Then third one is the generator behavior is divided into three periods. Subtransient periods lasting of for the first few cycles. Transient period covering a relative longer time. Last one is a steady state period. Thank you.